Hi, my name is Steve Redpath of Trans-Euro Engineering. We are a Sitting Guild and EAL approved electrotechnical training centre, and in this video I'm going to demonstrate how we carry out a continuity test on a final ring circuit. So this is the consuming unit of the circuit we're testing. We've already isolated the system, so this is a dead test, and we're going to now carry out the continuity of the conductors of the ring and the ring circuit being these sockets here. So there's 3 steps to a ring test. The first step is to measure the continuity of each of the individual conductors. So I need to remove those conductors from the circuit. So we take out the line conductors from the circuit breaker, known as R1. We then remove the corresponding CPC conductors, which are these, if I can find them, these ones here. And also the corresponding neutral conductors, which are these ones here. So we have the 2 sets of conductors that go around the ring to the sockets and then return. So what we first need to do is measure end to end on the individual conductors, known as step 1 of the continuity test. So for this we select our low resistance ohm meter, and before we start any measurements to get an accurate reading we want to null the instrument. So we turn it on, and with the leads connected together we can then check the resistance of the leads and null the resistance of those leads. So now the resistance we read between the ends of these probes will be purely the resistance of the conductors. So we then want to attach the low resistance ohm meter to the ends of the conductors. So the first measurement will be end to end on R1 of the ring circuit, like so. So we're connected on the ring, and then we test the continuity, and we have a reading of 0.83 ohms, and then we will record that value on the schedule of test results under the ring continuity column for the respective conductor, in this case little r1. And then we do the same again for the CPC end to end, or known as little r2. Measure that. We have a reading for that. And then finally, we record the reading again for little r2 on the schedule of test results. And then finally we do little rn and measure those readings as well. So we now have 3 readings, one for little r1, little r2 and little rn, and these are then entered onto the respective columns against the ring circuit on the schedule of test results. And that's step 1 of a ring continuity test. Once we've done that, we then have to start or consider the test for step 2, which involves crossing over the outgoing R1 with the incoming Rn and the corresponding incoming R1 to the outgoing Rn, like so. So we're creating a figure of 8 between R1 and Rn of the ring circuit. So to do this we can do it in various ways. I'm going to use a terminal block, or chock block as it's called, to make these connections. So we get a screwdriver and join R1 outgoing to the opposite, not of the same cable, but of the opposite twin and earth cable to the opposite Rn, like so. And then we cross over the other pair in the other terminal block, like so. Let's join those together. And with the R1 going in the opposite side, like so. Making sure they're nice and tight, so we've got a good connection to make sure we get a good, nice low resistance reading. So just double check those connections and just give them a tighten those up a bit. So now what we've done is we've created a crossover between R1 and Rn, a figure of 8 on that ring circuit. And part of the measurement now is to record or measure the continuity between R1 and Rn at each socket. So I'm going to use a socket adapter so I don't have to try and connect into the back of these. So I'm going to go across R1 and Rn of the socket, and then at each socket I'm going to measure the continuity of that figure of 8 circuit. Doesn't matter which circuit we start in, we're going to measure all of those. And if the circuit is connected up correctly, we've already proved we've got continuity on the individual conductors. Then if they're connected up correctly, the readings at each socket should be more or less identical. So we test on that socket, we've got 0.14 of an ohm. We test on this socket, roughly the same. And again on this socket, test again, roughly the same again. Now this socket may be a spur off the ring, so for that reason we may expect the reading to be slightly higher due to the increased cable impedance, and more or less the same reading again. So thereby we've now proven that the R1, Rn of that ring is connected, and it's connected up in the correct fashion around that circuit. There's no actual position on this schedule of test results to record this. This is the 17th edition model form. So step 2 is not actually recorded. Step 1 we recorded. We don't record step 2, we're just proving that polarity is effectively correct. And now we're going to move on to step 3 to prove that the CPC or R2 is connected correctly. So now we move the instrument over to R1 and R2. And now what I've got to do is change the connections to carry out step 3. So back to our terminal block in the consumer unit, we remove Rn, little rn, like so. And replace that with the corresponding CPC. So again what we're doing is creating a figure of 8 between little r1 and little r2 of the ring circuit. So I'm just running now like so. And move out the R1s out of the way. So now we've got a figure of 8 between little r2 and little r1. And again, with our low resistance ohm meter, we can then go to the socket outlets at each point around the ring, and this time measuring between R1 and R2 at each socket outlet. And we should again see a consistent reading. In other words, each socket outlet should be more or less the same reading. So that's one socket tested, move to the next one, and we get a similar reading. Move on to the next one, move on to that, same again, move on to the last one, and we have more or less the same again. So we've now confirmed that R1 and R2 are connected up correctly at each socket. Now this reading is effectively big R1 and big R2, the continuity value that we're going to record in this column here, and the big R1, R2 on the model form. And the readings we record each time are the highest values. It's the highest value that we're interested in, although if it's connected up correctly they should be more or less the same. So that completes the continuity test of a ring circuit. 3 steps, 3 sets of measurements, and we record step 1 and step 2 on the schedule of test results. And that completes a continuity test of a ring circuit. We can now replace or return the cables back into the correct connections in the consumer unit, and that completes the test. Okay, so that's the end of this video. You can see more of our test videos on our website at www.trans-euro.co.uk.